Good day, my students. You are welcome to the series of lectures organized by University Press PLC, the foremost publishers. As I earlier introduced, the lessons are introduced such that will equip you adequately for the examinations at SSC level organized by WAEC and NECO. Thank you very much. And I want to inform you that all the doubtfulness and the fear you normally have in mathematics will be removed. Today, we are going to consider theory of indices, logarithm, and sort. We are going to revise them as displayed on our textbooks. That is Mom Maths, published by foremost publisher, University Press PLC. Now, we are going to consider and revise another topics. The first one is indices. The second one is sorts and logarithm. Indices. They are what we call exponential expression. We have algebraic expressions. We have trigonometric expressions. Now, I want you to note this: 2x plus 5x. This is an algebraic expression, and you can say this is 7x. But 2 raised to power x plus 5 raised to power x will never be equal to 7 raised to power x. The two expressions are not the same. The first one is algebraic, while the second one is exponential. Now, let's look at theories on indices. I will not waste your time on this, but I refer you to our textbook, the More Mathematics for GS3, SS1, and SS2. And the first 20 pages, as earlier said, you see the preview of all what you need to acquaint with this topic. Now, the rules on indices. I want you to look at the following. The first thing, when I write 2 raised to power 1, this is 2 raised to power 1. When I write 2 raised to power minus 1, take note, this is 1 over 2. Now, when I write 2 raised to power x multiplied by 2 raised to power y, it is not equal to 4 raised to power xy, because this is an independent. This one does not depend on this, but because they are in the same base, you are free to add the index. Now, 2 raised to power x multiplied by 2 raised to power y is the same thing as 2 raised to power x plus y. For example, 2 raised to power 1 over 2 multiplied by 2 raised to power 5 over 2 is the same thing as 2 raised to power 1 over 2 plus 5 over 2, which is 2 raised to power 3, and so on. Now, we have the operations of addition, subtraction, solving on this. Now, 2 raised to power m divided by 2 raised to power n is the same thing as 2 raised to power m minus n. For example, 2 raised to power 7 divided by 2 raised to power 6 is the same thing as 2 raised to power 7 minus 6. Another one, 2 raised to power mn is the same thing as 2 raised to power m everything raised to power n, or 2 raised to power n everything raised to power m. For example, 2 raised to power 6 is the same thing as 2 raised to power 3 times 2, which is the same thing as 2 raised to power 3 all squared, which is the same thing as 2 raised to power 2 all cube. Please take note. Now any number raised to power raised to power 0 is 1, but you are not permitted to say 0 raised to power 0. It's mathematical absurdity. It doesn't have any meaning. Now let's look at this example. Let's say you are asked to simplify 2 raised to power 1 over 4 all raised to power half multiplied by 3 over 8 everything raised to power minus 1 over 3. We are dealing with indices. Though this is a fraction, this is also fraction raised to power. Now there is a way of dealing with just ordinary numbers or integers, but this is an exponential expression. This is also an exponential expression. We are not permitted to just start cancelling as we normally do when we are handling basic operation on fractions. Here the first thing to do is to change fractions under the bracket to improper one. 1 over 4 change to improper fraction will give you 9 over 4. Everything raised to power half. The second one, 3 over 8 change to improper fraction give you 27 over 8. All raised to power minus 1 over 3. Please take note. Note. The square root of any number is that number raised to power half. E.g., the square root of a is a raised to power half. The cube root of any number is that number raised to power 1 over 3. E.g., the cube root of a is a raised to power 1 over 3. Not only that, the inverse of a number is 1 over that number. The inverse of a is a 1 over a, which is the same thing as a raised to power minus 1. That is 1 over a equals a raised to power minus 1. Not only that, the inverse of a fraction, for example 1 over 2 inverse, is the same thing as 2 over 1. 1 over 2 inverse is the same thing as 2 over 1. In general, a over b inverse, a over b inverse is the same thing as b over a. So if you have a number raised to power the negative number, they only want you to invert it. They only want you to invert it. Let's use that method now to complete the questions. 9 over 4 raised to power half multiplied by 27 over a raised to power minus 1 over 3. Let's continue. Now over 4 raised to power half multiplied by 27 over 8 raised to power minus 1 over 3. Take note of how it is written. Please, there is no relationship between 2 and 4. There is no relationship between 27 and 3. Don't say 3 here 1, 3 here 9. No. Now separate them. You have to handle them term by term. This one means 9 raised to power half divided by 4 raised to power half. So you can say 9 raised to power half all over 4 in bracket raised to power half multiplied by, I told you, when you have an expression like this and the index is negative, you can invert it. A over B, no, like this. This is 8 over 27 raised to power 1 over 3. You invert it, the sign changes. You invert it, the sign changes. What is 9? 9 is 3 raised to power 2. 3 raised to power 2 bracket 1 over 2. Everything over 4. 4 is 2 raised to power 2. Everything raised to power half multiplied by 8. You express it in terms of 2. 8 is 2 raised to power 3 bracket 1 over 3 divided by what? 3 raised to power 3 bracket 1 over 3. Please take note. Look at this and this. They are on the same line. You are free to say this one cancel this. This one cancel this. The same thing. This one cancel this. This one cancel this. And this one cancel this. From here, we have 3 by 2 by 2 and we all over this and this. That is 3 all over 2 multiplied by 2 all over 3. You are now free. This one cancel this and this one eliminate this. So the answer is 1. The answer is 1. You have to tell them the reason why we are using this method. That is why if you check the book written by man, we don't want you to get confused. By the time you are giving this 27 over 8 and they say cube root, some will be thinking 8 here 1, 8 here 3 point something, and by the time they get decimal they will run into trouble. Take them one by one. Now let's look at another example. If we are asked, here we simplify. Now we want to solve. Method of solving algebraic expression is different from method of solving exponential expression. For example, if you are asked to find solve, here they won't say evaluate, they say solve. They won't say simplify, solve. That means you are looking for the value of a variable. Solve. Solve for x. If 1/3 of 9 raised to power x is equal to 27 raised to power minus x. This is exponential equation. My students, you are not permitted to say 3 here 1, 3 here 3. It is not allowed. But 1/3 of a number is that number divided by 3. So instead of saying at 1/3 of 9x, you can say 9 raised to power x, everything divided by 3 equals 27 raised to power 1 minus x. Now this is the same thing as over 1. Then you cross multiply. This is where we are going. In algebra, when you cross multiply, you just multiply like that. If you multiply 3 by this, the answer can never be equal to 81. because 3 is an integer. 27 raised to power 1 minus x is an exponential expression. They are independent. So this one will be 9 raised to power x equals 3 times, you are free to use that dot, not decimal point, times 27 raised to power 1 minus x. This can never be multiplied by this separately, because this one is loaded. Yes, there's something on his head. Now you change everything to the powers of 3. 3 is common. 3 is a factor of 9 and it's also a factor of 27. This 9 raised to power x is the same thing as 3 raised to power 2x equals 3 raised to power 3 is the same thing as 3 raised to power 1. Don't forget. And 27 is 3 raised to power 3 in bracket 1 minus x. The next step, we discovered that some of you normally say this one cancel this and cancel this. It is not allowed. The next stage is to equate the indices, equate the powers. Now here we have 2x. This is this multiplied by this. You are to add this and this, not to multiply. Because we discovered that some of we multiply because we say, see, this one is multiplication. It is this one plus this one. Because 1 plus 3 into 1 minus x. Now, 2x equals 1 plus 3 into 1 minus x. Let's continue. You know these simple linear equations, you are not just allowed without clearing the bracket. You could say you collect, you can't collect like times here. Now 2 raised to 2x equals 1 plus 3 into 1 minus x, isn't it? Then you open the bracket first. 2x equals 1 plus 3 minus 3x. Collect like terms. Collect like terms. 2x plus 3x equals 4. Here 5x equals 4. Then your x equals 4 over 8. 4 over 5. You leave it like this or you change it to decimal. Please, I want to advise you. If it happens that the value of x is something like 1 over 3, but because you are in a hurry, I want to give an example. Let's say your value of x somewhere is 1 over 3, but you don't want to write 1 over 3 down. Because you use your calculator, you say x is 0.33. They will give you 0 because that's what we call CAO when marking. CAO. CAO means correct answers only. 1 over 3 is not equal to 0.33. If you approximate, you are approximating prematurely. In fact, nobody asks you to do that. Or you say 1 over 3 is 0.3. 1 over 3 is 3 over 9. 0.3 is 3 over 10. Are they the same? They are not. So please take note. Now, that's the answer. Now let's go to another example on these indices. You know, I call it exponential equation. At times, the equation may be quadratic, cubic, quartic, but for a level, we limit it to quadratic. But we check our textbook, you see some questions there. That one is to take care of those of you that want to do one activity test or the other, like a post UTME. So please be here with us. Now, Now let's look at this one. Let us consider another example. 4 raised to power x minus 2 raised to power x minus 2 equals 0. This type of question is very common. But some of you, because of 4, 2, and 2, you think you just solve straight. No, this is exponential equation. And by the time you substitute, it gives you quadratic equation. This one is in quadratic form. Because 4 raised to power x is the same thing. 4 raised to power x is the same thing as 2 raised to power 2 all raised to power x, or 2 raised to power x all squared. Please take note. So this one will now be 2 raised to power x all squared minus 2 raised to power x minus 2 equals 0. This is quadratic in 2 raised to power x. You can solve it directly, or you let 2 raised to power x be another variable. Let 2 raised to power x, let it be a or b. Please don't use o or 0. If you say 2 raised to power x is 0, by the time you substitute and say 0 all raised to power 2, you may get stuck. Now, if 2 raised to power x is a, this one becomes a all raised to power 2 minus a minus 2 equals 0, quadratic equation. Then you can use factorization method. You can use the one you call almighty. There's nothing like almighty formula. Probably when you are in GSS1, you see long formula, you call it almighty. Or graphical method. It doesn't make sense to start using graphical method here. You may spend 5 minutes. So factorize. This is a minus 2 bracket a plus 1 equals 0. Two numbers are multiplied together, the result is 0. Meaning 1 is 0. Meaning 1 is 0, the other one is not 0, or the two of them are zeros. So here, this means a minus 2 is 0. This one implies a is 2. The second one, a plus 1 is 0. That one means a is minus 1. The question does not ask us to find a. We only use 2 raised to power x to represent our a. If you stop at a, if you stop here, you are halfway. You are halfway. If it is 5 marks, probably you will be given 2, because no work done yet. A is 2, a is minus 1. Then you have to interpret that one for us. A is 2, but a is 2 raised to power x. Some of you, this 2 is the same thing as 2 raised to power 1. This implies x equals 1. X equals 1. The other one, a equals minus 1. It is not possible to write this one in terms of this. It is not possible. Therefore, this, you can use that. That is all exponential equations involving leading to. There are some that will lead to simultaneous equation. You have to follow. There are some that leads to other simultaneous equation. One is linear, the other one quadratic. I will give you an example, but we won't work with them. But if you want to have as many exercises as possible, I refer you to Man Math. It's in book 2. The second chapter 3 is in book 1. In fact, the first 2 chapters is also in book 3 for that revision part. Now, let's go to the next topic. Logarithm. 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 Log of a number is the what we are used to decimal scale, that is base 10. But generally, you have to define what logarithm of a number is, because it may be in base 2, it may be in base 100, it may be in base x. So logarithm of a number, fortunately, more mass for SS1, if you look at the first 5 pages, is there. Logarithm of a number. More mass for SS3, chapter 1 and 2 is same thing, because that topic is very, very important. Logarithm of a number is the power a given base is raised to give you that number. The power a given base is raised to give you that number. That is why when you say log 100, because the base is not specified, you say 2. Log 100. We all know it's 2. They say, oh yes, it's 2. Some of you don't know. The reason is this. We are operating in base 10, in decimal scale. So log 100 is the same thing as log of 100 to base 10. For the fact that the base is not specified here means it is in base 10. And 100 is the same thing as 10 raised to power 2. So this is logarithm to base 10, 10 raised to power 2. By that definition, the power this base is raised is 2 to get 100. That is why log 100 is 2. The same thing, log 8, because the base is specified 2. Log 8 is the same thing as log to base 2, 2 raised to power 3. So log 8 is 3. I don't want to waste your time on this definition. I don't want to waste your time on this definition, but the general definition of logarithm of a number is this. Log of a number x to base a is y if and only if the value of x equals a raised to power y. This is general definition. Now let's use the in fact, if you are given any questions, use the general definition, you'll be able to get the value. For example, look at this question. Some of you may think that the question is wrong, there's nothing like that, there's this and that. Look at this, they says evaluate. They will say simply evaluate. Evaluate logarithm of 1 over 4 to base 2. That one is another one. Logarithm of 27 to base the square root of 3. Or logarithm of 4 to base 8. You don't need to crack your brain. Start thinking. How are you going to express 27 in terms of the square root of 3? No. Use the definition. I will pick just only this one, because we have numerous of the, you have plenty. If you, in fact, if you want to solve up to 40, they are there. Let's look at log of 27 to base root 3. Log 27 to base root 3. We don't know the answer, but let the answer be x. By our definition, log of this number is the power. This one is raised to get this number, and from here, 27 will be equal to the square root of 3 raised to power x. If you look at log 100 to base 10, I say the answer is 2. 100 is 10 raised to power 2. The base is raised to power 2. So in this case, the square root of 3 raised to power x equals 27 by general definition. And I told you earlier, the square root of a number is that number raised to power half. So the square root of 3 is 3 raised to power half. This one becomes 3 raised to power half That x will not be there, is up, equals 3 raised to power 3. This x is not to be here. Now what is the meaning of this? It means half of, you equate this. That means half of x equals 3. Half of a number is 3. What is that number? 6. Our x is 6. Therefore, log of 27 to base root 3 is 6. Now let's continue on this logarithm. We are okay with the exponential equations. Let's look at some expressions. We have logarithm equations as well, but we need to understand this. Log of a number a plus log of a number b to the same base, let's say base x and x, is the same thing as log of the product of a and b. I don't want to waste your time on that because our preview is there. Now to base x. Now if you are given, because they normally ask you to evaluate, and you are given logarithms of some numbers, for example, given logarithm of 2 equals 0.3010, comma, logarithm of 3 equals 0.4771, and you have to evaluate without using logarithm table. Without using it, don't refer to your table, don't say I have my own table. No, you have been given. They say evaluate log 4.5, log 1.5, log 1.2. This is the first one, this is the second one, and this is the third one. There are many of them. I only want to do only one because of our time. Now you are giving log. 5 is here, 5 is here. Please take off your mind from log of 5. Take off your mind from log of 5. Let me do log of 1.5. Logarithm of 1.5. Logarithm of 1.5. Now 5 is here. Don't think 1.5 is 15 over 10 and 15 is 3 times 5. You are not giving log 5, so keep off your mind from 5. Express this one such that 3 and 2 will be the only two numbers that will appear. 1.5 is 1.5 or 3 over 2. This is logarithm of 3 over 2. Put it in bracket. And log of 3 over 2 is the same thing as logarithm of 3 minus logarithm of 2. You have been supplied with log of 3 and log of 2. Substitute. Substitute. If you substitute here, this one will be 0.4771 minus 0.3010. Then you find the difference, and that's the log of 1.5. What I really want to emphasize here is because 5 is there, some of you will be thinking how you are going to express 1.5 as 1.5 as 5 and 3. 5 is not there. Don't manufacture 5. Now, I don't want you just simplify. Now, finally, before I say thank you, you have log of x plus 1 base 2 minus log of x base 2, and the question says is equal to 3. Please, log 2 minus log 5 minus log 3 is not equal to log 2. It's unlike just ordinary arithmetic. So log of this minus log of this is logarithm of the first divided by the second. So this one is logarithm of x plus 1 all over, you know, you have to let this bracket be like this, all over x equals 3 base supplied. If you look at that expression, log to base 2, log to base 2, x plus 1 all over x equals 3. By definition, logarithm of this is the power this is raised. So x plus 1 over x is 2 raised to power 3. Don't say you have to find log of 3. No. Or you say, oh, this is log 8. This means x plus 1 all over x equals 2 raised to power 3. So x plus 1 over x is 8 over 1. You solve, it becomes simple linear equations. Cross multiply, collect like terms, and find x. You have 8x equals x plus 1. 7x is 1. X is 1 over 7. Please, for God's sake, I know some of you are very, very good. From here, you say 7x is 1. You know x is 1 over 7, but you don't want to write 1 over 7. You write decimal. 0.14, this and that. That's the end of the road. Because the correct answer is 1 over 7. It's not 0.13 something. Thank you very much. Thank you for your patience. My name is Akabi S.O.